Hey, if you've spent any time reading reviews for countertop reverse osmosis systems like AquaTru, Waterdrop, or Bluevua, you've probably seen complaints like, after 8 months, the unit stopped working. Less than 5 weeks of owning it, it had already started to leak all over the place. Unfortunately, my happiness only lasted for 3 months when the filter completely stopped working. My first problem is that the unit would lock up, and broke just after a year. This is the second unit I bought that has failed in less than a year. And while it's easy to assume that these issues are caused by poor product quality or bad manufacturing, from the research that I've done, in many cases it appears they're actually caused by user error. More specifically, one easily overlooked but vitally important detail: the quality of the water going into the system. This video is meant to clear up the confusion. I'll explain the most common cause for premature failure of these systems, how to check if it applies to your situation, and a very simple solution to prevent it. So if you already use or are thinking about buying a countertop reverse osmosis system, definitely stick around. This could save you a lot of frustration and possibly hundreds of dollars. So hard water is extremely common across the United States, with most homes having hard water to some degree. Hardness is caused primarily by two minerals, calcium and magnesium, which naturally dissolve into the water as it moves through soil and rock. While generally not harmful to drink, these minerals can create a number of problems for water-using appliances, including water heaters, dishwashers, and yes, reverse osmosis systems. Now, here's where things get a little tricky. A reverse osmosis system can remove the minerals that cause water hardness. Technically, it does that very effectively, but that doesn't mean it should be used to do so. Why not? Because those hardness minerals don't just disappear cleanly. As they move through the RO system, especially when they pass through the membrane and internal tubing, they can begin to precipitate out and form scale. That lime scale buildup is what eventually clogs up the internal components, damages the RO membrane, restricts water flow, and eventually causes your system to fail far sooner than it should. So yes, RO can reduce water hardness, but it should not be used as primary treatment to do so. Every reverse osmosis system, whether it's a countertop model or a full under sink unit, comes with very specific operating requirements. These are usually listed in the user manual and outline the specific water conditions the unit was designed to handle. This includes things like temperature and pH ranges, maximum total dissolved solids or TDS, turbidity, and common groundwater contaminants like iron and manganese. And most importantly for today's video, maximum water hardness. These specs directly impact how long your system will last. If you filter water outside of these limits, you are setting yourself up for failure and likely voiding the warranty. Let me give you just one example. The AquaTru countertop RO system, one of the most popular on the market, specifies a maximum hardness of 10 grains per gallon. That's about 171 milligrams per liter. If your water is harder than that and you use the system every day, you're guaranteed to see scaling, leaking, and sooner than later, total failure. So if you're not sure what your system's operating parameters are, I'd recommend taking the time to look them up. They should be listed in the user manual or on the brand's website. And there's one more detail that often gets overlooked. Even if your tap water quality falls within spec, how you use the system also matters. Most countertop reverse osmosis systems have a tank that you manually fill with tap water, sometimes called the feed water tank or dirty water tank. As the system runs, it separates the unfiltered water into two streams. The filtered water, which passes through the RO membrane and is collected in the clean water tank or carafe, and the reject water, which contains all the contaminants the membrane has filtered out, including dissolved solids like the hardness minerals, calcium, and magnesium. Now, in most countertop RO systems, this reject water isn't drained away. Instead, it's recirculated back into the feed water tank while the system continues filtering. That means with every cycle, the concentration of contaminants in the feed water tank increases. So if you simply top it off with more tap water instead of fully emptying first, you're gradually raising the TDS and hardness of the feed water beyond what the system was designed to handle. Over time, this elevated mineral content can lead to the exact same scaling and internal damage as untreated hard water, even if your original tap water was within spec. So it's vital to always make sure to empty the feed water tank completely before refilling. So to figure out if your water meets the specs of your RO system, you'll need to determine its hardness level. If you're on city water, your provider is required to publish a consumer confidence report once a year. This report includes information on things like lead, chlorine, and bacteria, but unfortunately, hardness is not a required parameter, so many providers don't include it. That means you might need to test it yourself, and fortunately, it's easy and inexpensive. You can use either a hardness test strip, similar to a pool test strip, or a liquid titration kit, which is slightly more accurate and still easy to use. And I'll link up everything I talk about through the video for you guys down in the description. If your water tests above 3.5 grains per gallon, it's considered moderately hard. And in the water treatment industry, we usually recommend pre-softening the water before it goes through a reverse osmosis system if it tests harder than about 7 grains per gallon, which is about 120 milligrams per liter. So what do you do if your water is 8, 15, or 20 plus grains per gallon, which isn't uncommon in the Midwest, Southwest, or mountain regions? If you own your home and want to soften all the water coming into it, a whole house softener might make sense. But many of you watching this are likely renting, so that's probably not an option. That's where portable water softeners come in. These are small, self-contained softening units that work exactly like the big whole house systems, but they're designed to be compact, portable, and easy to connect and disconnect. No power required, no permanent installation, just hook it up, add some salt when needed, and you're good to go. By softening the water going into your RO system, you remove the minerals that cause scale before they get a chance to damage anything. I actually recommend this same portable softener setup for people in apartments or rentals who are dealing with the effects of hard water in the shower. So if you're interested in that video, I'll link it up down in the description too. Now I'm going to show you step by step how to install one of these portable softeners underneath your kitchen sink to soften just the cold water. So here's what you'll need. A portable water softener, of course. I personally use the on-the-go 16K grain model, but if you're tight on space, an 8K model will work just fine. It's about half the size and functions the same. It'll just need to be regenerated more often. Compression adapters to reduce the 3/4 inch male ports on the softener to 3/8 inch male threads that match your sink's compression hoses. Now, make sure to check your specific fitting sizes here. Kitchen sink connections are usually 3/8 inch, but in some cases they're 1/2 inch. If you can find 3/4 to 3/8 inch male adapters, that would be great. But in my setup, I had to use a 3/4 to 1/2 inch bushing, followed by a 1/2 inch to 3/8 inch coupling on each port. Either way, it works the same. A compression faucet supply line, this connects your cold water shutoff valve to the softener inlet. Depending on your valve, this will either be 3/8 to 3/8 or 1/2 to 3/8. So to install, first attach your adapters to the inlet and outlet ports of the softener. Turn off the cold water supply valve under your kitchen sink. Disconnect the existing cold water supply hose that runs from the shutoff valve to your faucet. Connect the softener to the cold water shutoff valve using your compression supply line. I actually found it easier to attach it to the softener first, since there isn't much space to work with under the sink. And finally, take the original hose that fed your faucet and connect it to the outlet side of the softener. At this point, all your connections should be in place. Before turning the water back on, it's a good idea to remove your faucet aerator. We're going to flush the softener for a couple minutes to clear out the resin bed. Turn the cold water supply valve back on slowly and check for leaks as the softener pressurizes. Then turn on the cold water at your faucet and let it run for a few minutes. You may notice the water appears yellow or orange at first. This is completely normal. It's just the softener resin flushing and the pressure equalizing. Once the water runs clear, you can reinstall the aerator. Just keep in mind that the water may look cloudy for a little while. This is due to tiny air bubbles introduced during the flush. It's harmless and should go away with use. If you want, you can leave the aerator off for a day or two to minimize those bubbles while things settle. And that's it. you now have a fully functional, localized water softener feeding your kitchen faucet. From here, you can safely use that water to fill your countertop RO system without worrying about scaling or premature system failure. If you're using a countertop reverse osmosis system and your water is even moderately hard, pre-softening is the best way to protect its longevity. These systems do an outstanding job of purifying your drinking water, but they're simply not designed to handle elevated levels of calcium and magnesium long term. And as you've seen, filtering hard water through them is one of the fastest ways to shorten their lifespan and cause premature failure. Installing a portable softener is a relatively small and affordable upgrade, but it can make a huge difference in protecting your investment. It can easily save you hundreds of dollars by preventing internal damage, avoiding replacement costs, and keeping your RO system running smoothly for years. Make sure to check out the description where I've linked up everything you'll need for this setup. And again, if you want to see how this same approach can help with hard water in the shower, check out the next video coming up right now. Click or tap to keep watching.